This is a Diacro bender. It is called a Diacro bender because that is the name of the company that makes the machine. As you can see, Diacro, DI-ACRO, Diacro. What this machine does is it can bend circles or arcs with specific radius. So there are dies that go in the center of the machine, and the arm pivots around that center, allowing us to bend around this radius. 7/8 R, or 7/8 inch radius, or 1 3/4 inch diameter. So if I needed to make a 1 3/4 inch diameter metal circle, I would use this die. This is just a piece of band cut and bent into a circle. I also don't just have to use circles. I can bend a quarter of this arc and then turn the metal around and bend the opposite way. So I can make different shapes and curves using a 7/8 radius. So the radius is the size of the curve you'll get, right? And the diameter is the entire circle. So I have a lot of dies here, from very small to getting larger. I also have dies that can bend round bar or tubing, different diameters, 3 different diameters. And I also have a larger die that can bend much bigger tubing. The biggest thing with this machine is this center hole. It is only one size, and all of the die sizes range. So you have to use a 1 inch round in the center. Some of these have 1 inch rounds on them, like this bottom of this die, 1 inch round. So you have to have a solid 1 inch round inside the center, like this one. But you can't confuse this die. That side is the 1 inch round, not this side. You cannot put it in this way, and some people do. They'll stick it in there. This is not the 1 inch round that you use to bend this way. You don't put it in this way. You put it in this way and use the smaller end as the die. If you want a 1 inch round, you use the 1 inch round. Okay? Like this small one, it has a 1 inch round on the back side. Now, these larger ones, all these ones here have 1 inch rounds that I can put directly into the machine. All these others have different setups where I have to put the 1 inch round in and then put the die over the 1 inch round. So you have to be aware of what you're setting up and how you're setting it up. Always use a 1 inch round in the center hole. No matter what die you're setting up, the 1 inch round goes inside the center hole. that is how the dies are set up. So depending on what size you want, or radius or round you need, that's how you set up the tooling first. All of the dies are kept on the shelf here so that they are easily accessible and we always know where they are. The dies are kept on this shelf right here. If I need to make a 1-inch circle, I've got to know how much straight material I need first. So how do you know how to measure how much metal you will need to make a circle around that die? Well, it's easy. It's the formula for circumference. The circumference of a circle. So the formula for circumference is pi d. So pi times the diameter. In this case, the diameter is 1. So pi is the circumference, or 3.14159. So you can round to about 3 decimal places, so 3.141. But I don't need to be that accurate with this. So as long as I round down to the closest 16th on a ruler, I will be fine. In theory, I am supposed to be taking into consideration the thickness from the middle of the material. So as this goes around, I have to count for the material right through the middle all the way around. Well, half the material here and half the material here is the thickness of the material. So now if I have 1 plus the thickness of the material, I will be calculating it correctly. Because if you just try to wrap this around, if I cut this to 3.142 or pi and try to wrap it all the way around this, it won't make it the whole way. It'll be a little bit short. So, because I didn't account for the material thickness. So, I have to account for the material thickness when I'm calculating how long of the piece of metal I need. So, 3.142 plus the thickness of the material. So let's find out exactly how thick this material is. This is a caliper. Every graduation you see around this dial is 1/1000th of an inch. That is 0.001. If I go up to 10, 0.008, 0.009, 0.01, 0.011, 0.012, 0.013, 4.015, 0.016, 0.017, 0.018, 0.019, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.1. Okay, now that you understand how the caliper works, I can measure this material. So I open the jaw, close the jaw on the material, and what does it read? There is also that part of the dial where it says 0.1, because I've already gone around the whole dial once. Then it will show a 1 down here. That down here, now there's a 2 if I go all the way around the dial twice. A 3 if I go around 3 times, 4 times, 5 times. So 5 times around the dial is 0.5 or a half an inch. So that's a half an inch opening right there in that jaw. 6 times around the dial, 7 times around the dial, 8 times, 9 times, 10 times around the dial equals 1 inch. So then you go around again and it's 1.1, 1.2, 1.3. So now if I close this around the material and look at the dial, I've got showing a 1 down here and a 22 or 21 and a half over there. So we'll say 21. So what does that caliper read right now? 0.121. So it's almost an 1/8 inch because an 1/8 inch is 0.125. So we'll just call this material 0.125. Okay, this die has a 1 inch radius. So it is a 2 inch diameter. If I were to bend around this 1 inch radius die, it would be a 2 inch diameter inside diameter ring, because I am bending the metal around this form. It would be the inside diameter of the ring. Whenever you are bending anything, you need to consider the inside plane of the material. So as I bend this, I'm considering an inside line between the thickness of this material all the way around. If I consider both sides, it is the thickness of the material. Half of the material here on this side and half of the material here on this side. I'm considering bending through the middle of the material. So half the material here and half the material here would actually just be adding the thickness to my formula. So this is 1/8 inch material. So the diameter would be 2. So I need to say it's 2 1/8 times pi to get the right size material to bend around this die correctly. Okay, so 2.125 times pi equals, which we can round down to at least 3 decimal places to 6.676. This is where you have to start thinking about how fractions equal decimals. I need to find my closest fraction that I can measure on a ruler at 1/16 of an inch increments to 6.676. What fraction is closest to 6.676? Well, I know 0.5 is half. So after half is 8/16. So the next 16th increment would be 9/16. So what is 9/16 in decimal? 9 divided by 16 equals 0.5625. Okay, not close enough. I need 0.676. So what's 10/16? That would be 5/8. So 5 divided by 8 equals 0.625. That's pretty close. 0.676 is only 0.04, or it's only 0.05 away from that. That's 50 thousandths of an inch. 0.05. Let's see if the next fraction is closer. So that's 10/16. What's 11/16? 11 divided by 16 equals 0.6875. So that's even closer, right? So I'm looking for 0.676, right? So 11/16 is extremely close to that. It's only 0.01 away from it. It's 0.01 more. So I'll use 11/16 when I measure. And I will cut a piece of flat band stock, 2, 6, and 11/16. Okay, so I cut my piece, and I ended up about a 1/16 short, which is fine, because the accuracy on this is not that important. And that 1/16 gap at the end is going to make sure it actually closes. But that's why we're measuring to 16ths, because every process adds more error. So as I measured it, I could have had error. Then when I went and cut it, I could have had a little more error, and it could have compounded into that 1/16 inch loss. But that is all right for what we are doing. The amount of error that we have is not that much for what we need to do, which is just bend this metal around a die, around this die. Also, after I cut the piece and deburred it, I sanded off some of the mill scale on the ends, because I'm going to be welding this ring together. So I cleaned up the ends and around the sides for when I weld it. Plus, I sanded in the middle. I didn't get all the mill scale off or anything. I just sanded it smooth. So for when this is done being shaped or put together, I will probably want to paint it. You're going to have to do this once it's all done too, because after welding there could be more pieces, a little spatter and stuff, but you want to clean all your pieces up before you put them together. Then when they're all together, do a final sand on the whole piece before you paint. Okay, so the first thing I need to do is set up the machine. Now, the handle, so you can set it to how thick your material is or how big or small your dies are. So I need to be able to put my die in first, and with the way the machine is now, I can't even fit the die on there, so I've got to move it back. With this die, I'm using the 1-inch center, and then I put this over top. And now I need to move this back because I don't have enough room here. Once I loosen these 2 bolts, I can slide this back and then slide this back. I can remove this front bolt totally and move it even further back. I can go all the way out to here if I need to. Then I just remove this bolt and move it even further out. But let's see where I land right now. Now that the nose of the tool is far enough away, I have to set it for the correct material. So to do that, I put my material up against the die and slide the nose of the tool up against the material. Once I have the nose of the tool against the material, I can now push up the locking spacer to the nose tool. And once I have everything pushed against the material, I can tighten these 2 bolts. Okay, so with the nose of the tool, it needs resistance, so when I put material in there and I bend around, it has resistance enough to bend the metal. When I pull back this way, it loosens. Now, the reason for this is so that I can change direction. So right now, I cannot bend this way. It just moves the nose out of the way. So I need to bend and pull the handle this way for the machine to have, for the nose to have resistance on it. I can change that with this switch. Just put the switch in the opposite side, and now I can bend this way, but not this way. Okay, so this just controls the direction that you want to pull the material. Pull the handle, bend the material. The next thing I have to do now is set my pin. Your pin holds the material in place while you bend it. You need resistance. So the pin will hold the material in place as you bend it. You want the pin as close to the material as you can get it, and still have the material fit between, like that. So I am going to be bending with the pin there. Now, this has a little pull handle on it too, because you want to turn the pin. It's almost like a cam, where you turn it and it will tighten the material in there. Sometimes you can't even get it tight enough, so I have also a wrench here that you can put on it to hold it in place. So now I have my location. Now I'm ready to bend. So on the first bend, we want to go a little less than halfway, because we need to complete one whole side of this bend first. If I put this up here and tried to bend this all the way around, I would not make a complete ring. I would have a flat spot at the end. So I've got to bend it in two halves. I need to complete the first half of the circle. So I'm going to start about halfway, a little less, pull the handle all the way back, put the nose against the metal, and then start bending. And I'm just going to pull it right around. And if this happens, if it starts pulling through, either put some pressure with your hand on the pin or use the wrench. And I'm going to go all the way up to the end of the metal. On the first side, it's good to pop right off. Now I can pull the pin, and I've got that side bent. Now you can see that this curve, it goes all the way now. We have to do one side first and then turn around and do the other side. If we didn't, there would be a flat spot at the end of this. So it's curving all the way around. So now I'm just going to turn it around and do the other side. Now this is the side that you might want to have the wrench for, because now that it's already curled on this side, it's easy to spin right around this die. So it's good to have the wrench on it to make it nice and tight with the pin as you're bending. So first get it out of the way, pull your handle back, put your material through, get the wrench on it, put some pressure, and start finishing your bend. You can get a friend to help you hold the wrench if you need to. Change positions if you need to. See how it's rotating? It does get a little hard sometimes if you're in the wrong position, but you can keep readjusting and getting a new position. And now I want to make sure I go all the way to the end. That's it. Pull back a little, take the pin out. And that's my ring. Now, it's a little loose because it's not closed all the way. The metal has spring back in it. So what we're gonna do is close this now in a vise or a clamp and weld it together. So that is how you calculate metal size to make a circle. These clamps are good for setup, for welding the circles together. You're gonna have to set the seam on the side here so that when you do clamp it closed, it actually closes. And of course, if you're not exactly lining up, you're going to want to put it in the vise and straighten it with the pliers a little bit first. All right, so I straightened up the circle a little bit and I got it in the clamp. I don't have it too tight. I didn't squeeze it so it was real tight together. If you do that, it's probably going to push out of shape a little. So even if you have a little, they just meet, or if you have a little gap there that you can fill in, that's probably better. You also don't want to weld this on really too high of an amperage because it will melt right through. And watch the ends, because the ends will melt. If you're using the 1/8 inch 6013, probably about 85 amps, and make sure the metal's nice and clean like this to get a good fusion. So I'm definitely not gonna arc out here at the end. I'm gonna arc a little bit in and let the weld push to the outside. Then I'm gonna weld up to about here. I'm not gonna weld all the way to the end because I could melt this end off. So I'm just gonna stop and then I'll turn it around, clean up the weld, and then I'll just push a little more weld from here out. Then I can grind all this clean and it'll look like one solid ring. Okay, like I said, there was that one little void up here at the top, but that's a solid ring now. That's all you really need to do. You can go back and fill that in if you want, but you don't want to melt it more than it already is. So if it's something that you can just put that on the bottom, then you got a perfect ring here. So that is how you make a circle on the Diacro bender.